Hi everyone, it's Coach Fred here, and today I'm going to be going over how to divide polynomials using method 2. Yesterday we talked about dividing polynomials using polynomial long division. Now I know that this is a new thing for you because we've been spending months and months working on how we multiply polynomials, whether it be two binomials or a binomial and a trinomial. But there is also a need for us to be able to divide polynomials. So right now, I'm just teaching you how to divide them. And in our next lesson, we are going to look at what all of that means. We're going to put it all together. But for now, let's learn this other method called synthetic division. I'm going to show you the algorithm for that. Remember, algorithms are the recipes of how we can do something. So synthetic division is a shortcut. But you know what's interesting is it really can only be used when I'm dividing by a linear factor. So it can only really be used in one case. So what do I mean? So look at this one. It says x cubed minus 14x squared plus 51x minus 54. It wants us to divide it by x plus 2. That is what we're dividing by. That is a linear factor because the highest exponent of x is 1. So I can use synthetic division. But if it was like x squared plus 2, that's not linear, that's quadratic. I could not use synthetic division, so I'd have to do long division. So I know that you're going to really like this method, but it really can only be used in certain cases, so we do want to be careful. All right, so how do we use the method? Well, first we have to take that factor and we have to find its divide. We have to find. Okay, so we have to take x plus 2, set it to 0 to get x equals negative 2. That's the number that I'm going to work with to synthetically divide it. So you can kind of see it looks like it's the opposite in this case of x plus 2. So I take that negative 2 and I'm going to write it. I'm going to put it in a little box like this. Now there's a couple different ways you could write it, but that's the way I do it. All right, then I take the coefficient of each of the terms of the polynomial. Now, I always also want to make sure, just like long division, that there's not any missing terms, meaning if it went from x cubed to x to plain old to 51x, then an x squared would be missing and I would have to deal with that. And I'll show you that in the next example. But for this example, I have all of my every degree from x cubed all the way down to a constant. They are in standard form, so I take their leading coefficients or their coefficients. So in front of x cubed, I have a 1. I'm going to give some room. In front of x squared, I have a negative 14. In front of 51, in front of x, I have a 51, and in front of 54, I have a negative 54. Okay, so now here's the process. The first thing we do is we bring down the first term. In this case, it is a 1. So I'm going to put a 1 right here. Then I multiply that number, whatever I brought down, in this case 1, to the negative 2. So I multiply 1 times negative 2, and then I'm going to put it right above the line here. So 1 times negative 2 is negative 2. Then I'm going to add these terms together. So I add down. That gives me negative 16. Go through that process again. I do negative 16 times negative 2. That gives me a positive 32. I'm going to write it above the line right here. I'm going to add the numbers down. 51 plus 32 gives me 83. Okay, now follow that same process. I'm going to multiply negative 2 times 83, giving me, what is that, 106? I'm sorry, 166. But it's negative, so negative 166. And then I add down, and that's going to give me, let's see, 10, 2, and 2. So negative 220. And I'm done because I've run out of numbers, just like I did before. Now, what we saw when we did long division is that number, that last thing we ended up with, became our remainder. Right there, that 59 in that last example we did. So now my remainder is 220. Okay? That's my remainder. Okay? So, but that the dividend, or what, x minus 2 times this we call this the depressed polynomial. If I'm going to rewrite this now using what we did with long division, like I'd need this part, wouldn't I? That 2a squared plus 6a plus 18. So I take my they call this the depressed polynomial, or these numbers help me write my depressed polynomial. So I go down 1 degree from the original, which was x cubed, and these become my new coefficients. So this would become x squared minus 16x plus 83. Then I would take my remainder of negative 220. So I would subtract 220 over my original divisor of x plus 2. So that is my new polynomial. So I know that x squared minus 16x plus 83 minus 220 all over x plus 2 times x plus 2 will give me x cubed minus 4x squared plus 51x minus 54. And believe me, I understand that that looks funny. So what I thought I'd do is give you a quick kind of introduction to what it means. So look at Desmos with me here. Let me move it so you can see it a little bit better. I put in the function that we were working with, the polynomial, x cubed minus 14x squared plus 51x minus 54. And then I actually took that and I made a table. And I plugged in negative 2 into that function. That's my input. X was my input. The output that I got was negative 220. That was my remainder, right? So let me bring you over to the graph a little bit. Let's see if I can make this a little bit better for us. Let me see if I can. So that's telling me at that point, negative 2, which is going to be way down on my graph. I'm going to have to go way down. At negative 2, I'm going to have a point on the graph of negative 220. So that remainder does help me. It doesn't give me a 0, but it does give me a point on the graph. Okay, let's look at another example. Example 2. So we want to use synthetic division to divide x to the 4th minus 2x cubed plus 13x minus 6. I want to divide it by x plus 2. Okay, so first, I want to set that factor equal to 0, okay, to get negative 2, and that is the number that's going to go inside my box. I'm going to put the coefficients of every term and making sure that I put a placeholder 0 if there's any term missing. Now it's in standard form and I can clearly see that the x squared is missing. So I have to pretend that there's a 0x squared in my polynomial when I write my coefficients, because you can't skip terms. And that's a really important thing in both long division and polynomial synthetic division, okay? All right, so my coefficients would be 1, negative 2, 0, 13, and negative 6. I'm going to bring the 1 down. Then I'm going to multiply negative 2 times 1, and I'm going to write my number up. So that's going to give me negative 2. I'm going to add down. So that's going to, when I add down, I'm going to get negative 4. Then I'm going to multiply negative 4 to negative 2. That's going to give me a positive 8. I'm going to add down. Okay? All right, I'm going to multiply 8 times negative 2. That's going to give me negative 16. I'm going to add down. That's going to give me 3. Okay, now then I'm going to multiply negative 2 times 3, which is going to give me, that's going to give me negative 3. So that's going to give me a positive 6. So when I add down, I get 0. Now remember, that last spot, if I kind of put a little line here, this is my remainder. But hold on there, mama, because now my remainder is 0, and that actually tells me something. That tells me that negative 2 is a root of the polynomial. It is a 0 of the polynomial. It is an x-intercept of the polynomial. And this is one of the reasons we use synthetic division. Synthetic division is a really quick and easy way for me to find the zeros of a function if it's not factorable. Because if I can't factor it, I need another way to do this. So now I know that negative 2 is an x-intercept of this function. Now, let's talk about what our depressed polynomial is. Our depressed polynomial would be, remember, we go down a degree, so x cubed minus 4x squared plus 8x minus 3. All right, now that is my depressed polynomial, so I know that that times x plus 2 will give me my original polynomial, x to the 4 minus 2x cubed plus 13x minus 6. Now, this could actually be factorable or not. If it's not factorable, we're going to get into ways to actually do synthetic division again, and that's going to be in a future unit. So for now, I'm really excited because I got this 0 to be a remainder. What that tells me again is that negative 2 is a root or a 0, and guess what? x plus 2 is a factor of the polynomial. All right, let's look at another example. All right, so let's take those first two examples and put it all together here. If I tell you, I say, if -5 is a zero of the polynomial, find the other factors by using synthetic division. Okay, so if -5 is a zero of this polynomial, that means when I do synthetic division, I'm going to get a remainder 0. But that depressed polynomial is going to mean more to us if it's a 0. So let's test and see what happens. All right, so I'm going to get my algorithm going by taking my -5, putting it in the box, putting my coefficients. I'm going to write out my coefficients. I'm going to bring down my first term. I'm going to draw my line. I'm going to put my 1. Now I'm going to multiply. So -5 times 1 gives me -5. Ooh, let me use a better color. I'm going to add down. That's going to give me 2. I'm going to do -5 times 2. That's going to give me -10. I'm going to add down. That's going to give me 40, -48. I'm going to do -48 times -5. That's going to give me 8 times 5 is 40. And so that's going to give me 240. So positive 240. I'm going to add down and I'm going to get a remainder of 0. Okay. So I already knew that, right? I wanted that remainder to be 0, and I knew that remainder was going to be that last digit. But now because it wants us to find the other factors, we're really going to hope that our depressed polynomial right here, x squared plus 2x minus 48, I really want that to be factorable. So I want to know, are there factors of a -48 that add to a positive 2? So let me think about that. So I have -8 and 6, or I have -6 and 8. So -8 and 6 give me a -2, and 8 and -6 give me a positive 2. So these are going to be my factors. So I have x plus 8, x minus 2. So my original factor would be x plus 5. Remember, it's the opposite of what that 0 was. And my other two factors would be x plus 8, x minus 2. And if I multiply them all, I'm going to get a degree 3 polynomial. So I know it's could have 3 real zeros. So let's see. I've got -5's a 0, -8's a 0, and 2 is a 0. So I know that my graph is going to cross the x-axis at -5, -8, and 2. All right, guys, I hope that was a helpful video for you today. I know it was a lot, but when you try the practice, if you need to go back, at least you have something to go back to. Have a great day.